and another wonderful video on finding surface area of a three-dimensional object. And in this problem, we are going to be looking, I should actually say problems, we are going to be looking at finding the surface area of a pyramid. As was mentioned in my previous video, if you haven't watched that one, first watch that one on surface area of prisms. I did talk about what a prism was, and I also talked about what a pyramid was. So just to remind you, a pyramid is when we have one base, which could be triangular, it could be a square, it could be a rectangle, it could be a pentagon, it could be a hexagon, it could be any number of sided polygon. And then the faces are made up of triangles, and they have to meet up at a vertex point. So if I were to look at, for example, this top picture up here, you can kind of see my cursor. This is actually a very, very famous Parisian museum. It's called the Louvre. I think I'm saying that right. And it is actually a pyramid, and the base is a square. And it's a little bit hard to see in this picture, but I kind of like this picture because you can see all the people kind of waiting to go in. And so you're kind of missing the point at the top, which is called the vertex point. So how do we find the surface area? So looking at this very first picture of the Louvre, I want to think of it as its different parts. So the surface area in this situation is going to be the bottom piece, which is a square, and it's going to be 4 different triangles, and because the bottom is a square, all 4 of those triangles are going to be congruent. If the base happened to be a rectangle, then it would be a different story. We would have 2 that were congruent and then 2 others that were congruent. So for me to find the surface area, I need to find, so I'm going to first go ahead and just write that out. So right here, if I put surface area, it is going to be, as I said, it's going to be the square plus the 4 triangles. Okay, I know that kind of went off a little bit. Let me see if I can move this over a little bit. It doesn't look like it, but that's all right. Okay, so that's what I need to do to find my surface area. So now I haven't mentioned the dimensions. So the dimensions of the Louvre are actually, the base is approximately 35 meters by 35 meters. And the height of the pyramid is 22 meters. So looking over here at this other picture that I have, we can see that they told us the base. I'm going to go ahead and put it over here. I'm going to say that the base is 35, and that's meters, but I'm not going to write that down. I'm just going to kind of remember that in my head. So this is 35, and this over here is 35. And they told me that the height of it, so the height is the perpendicular distance from the vertex point, and it could also be marked over here. Okay, the height of it is 22 meters, which means that this length inside, that height is 22. Okay, so I want to be careful when I'm talking about the height of the object versus the slant height. Okay, the slant height would be this height right here, which is also perpendicular. Okay, it is perpendicular to the base, but it's not the same as this length. Okay, and if I think of that right there, I can see that that's creating a right triangle. So you might be wondering, why is Miss Morrell talking about that? Maybe I don't care, I don't need that. Actually, you do need that, because if I'm going to find the area of this triangle, it's going to be the base, 35, times this length. Okay, so I am going to have to find that length. So some of you might be wondering, how are we going to do that? Well, as mentioned, because the height is perpendicular, it's coming down. This is a right angle. It's also coming down straight to the midpoint. So it's cutting this length, it's coming halfway down. So half of 35 is 17.5. So this length right here from E to F is 17.5. I'm going to go ahead and just write that in there. So that is 17.5 meters. Right triangle, right triangle. Looks like I have those two legs. So how could I find the hypotenuse? That's right, I'm going to use Pythagorean theorem. Okay, so I'm going to use Pythagorean theorem to find that length from the very top of the vertex to that point F, which is called the slant height, or it is the height of one of those triangles. So Pythagorean theorem, I'm just going to go ahead and do that right over here. So Pythagorean theorem, I'm just going to put Pythagorean theorem would be 22 squared plus 12, so plus 12.5, excuse me, not 12.5, that is 17.5 squared is going to equal that length from the vertex to F, which I'm just going to call, because it's also a hypotenuse, I'm going to call it just the C, so that's C squared. Okay, now with my calculator, I'm just going to go ahead and do 22 squared plus 17.5 squared, and I'm going to add those two together. That is 790.25 squared. I think I'm going to go right over to here and just kind of put that there. So that is 790.25 equals C squared. I know I'm going a little bit into that essay, but that's okay. And then what am I going to need to do from that point? I'm going to need to square root both sides. So 790.25 square rooted ends up being 28.1. All right, so I'm just going to actually go ahead and get rid of that now because I do think you guys know how to find Pythagorean theorem. So that length is 28.1. So I'm going to go ahead and just write that in. So right here, that is 28.1 meters. Okay, so I am now ready to find my surface area. So my surface area is going to be this area of the square. That's easy, 35 times 35. 35 times 35 is 1,225 plus, and then I'm going to have to do 4 times the area of one of those triangles. Again, why am I timesing it by 4? Because there's 4 congruent triangles. All right, so I'm going to have to do the base. The base, again, is this length right here, which is 35. So it's going to be 35 times 28.1. So I'm going to go back to here. All right, right here. So that's, what did I say that was? That was 35 times 28.1. And then I'm going to have to divide that whole thing by a 2. And actually, I want to do that on the end here. Okay, let me divide that by a 2. All right, so let me go ahead and do that. So I'm going to do 35 times 28.1. I'm going to then times that by 4, and then I'm going to divide by 2, and I am going to end up with a surface area equaling to 3,192 meters, and I am going to put squares. All right, so that is my surface area of a square pyramid. All right, moving on to the second shape that you can see that I have over to the left of me. I have, first go ahead, let me get rid of some of this. Okay, all right. And let me move this up a little bit. All right, moving on to the next shape. Who can tell me what that shape is? It looks like, yes, it's a pyramid. Thank you. And what is the base? Well, it looks like we have 1, 2, 3, 4, 5, 6 sides. So the base is a hexagon. So for me to find the surface area, I am going to be finding, so my surface area will be the area of a hexagon. So I'm going to abbreviate that just hex plus how many triangles am I going to have? Now I'm not stating this, but I am going to now state that that hexagon is a regular hexagon, meaning all the sides are the same length. So I'm going to have 6 congruent triangles. So I'm going to have to do 6 times, again, base times height, divided by 2. All right. Now looking at that, all right, so that's basically what I'm going to have to do is find the area of the hexagon plus 6 times base times height divided by 2. All right, hexagon. I do have to be given some information here. Let's say that I am given that the radius of this hexagon is 6. So that would mean that from this center, if I break that up again into triangles, I'm going to have 6 congruent triangles. And they're telling me that this length right here, the radius, because again, I have to think of that as being inscribed in a circle, they're telling me that that radius is 6. So that means that's 6, and that means this is 6. Now, the other piece of information that they're giving us in this problem is they're giving us the slant height, which is nice. I'm not going to have to use Pythagorean theorem to find it. They're telling me that the slant height, that's this length, and of course you have to visualize that that is a line segment, okay? Not my poorly drawn line there, but okay. That slant height is 10. Now, if they had given me the height, as in that first example, I would have to then use Pythagorean theorem to find that slant height. This problem, that's not the case. Okay, but I do need to find the base of this triangle, and I also do need to find the height of that triangle. Lots of triangles in this problem, okay? So let me just go back. The reason why I want to find the area of this triangle is because I want to find the area of this hexagon. So I'm doing as we did a few weeks ago and we've been practicing, I'm finding the area of that regular hexagon. Hopefully you remember that the central angle right here would be 60 because I would do 360 divided by 60, but the height then goes and cuts that into 2 equal pieces, which means that that's a 30-degree angle. So again, there's my 30, 90, that's a 60, that's my special right triangle. So if this is 6, I know that across from it this is 3, and that's 3, which makes sense. That means the base of that hexagon or the base of that triangle is 6. Now, I didn't even have to really use special right triangles to know that, knowing that that was a 60-degree angle and this is 6 and 6. That means those are both 60. It's got to be an equilateral triangle. But still, I now have the base, and the height of that, using again my special right triangles, would have to be 3 times square root 3. All right. Okay, so I am set to go back and find my equation of, I'm set to go back and find the area of this hexagon. So it's going to be 6 of these triangles that are all the same. So I'm going to go back and I'm going to put right here my surface area is going to be 6 times the base of that triangle in the hexagon is 6. So it's going to be 6 times square root 3. All right, 6 times square, actually, 6 times 3 times root 3. Let me go back and put right here times, I need that 3, okay? So that's my base, that's my height, and then that whole thing is being divided by 2. I don't know if you heard my dog in the background right there. She's, yes, listening to me as I'm making this recording. All right, so that's the area of my hexagon. Again, That 6 in front is for each of those 6 triangles. And now I have, this is the base, 6 times 3 root 3 divided by 2. All right, plus, now I have to find up above, I'm going to have again another 6. And now I'm finding the area of this bigger triangle, one of the triangles that's the side. So that's going to be the base, which is still 6. This is going to be 6 times the height, which is 10. And then I'm going to have to divide that by 2 as well. So 6 times 10 divided by 2. All right. Let me go ahead and pull out my calculator and figure this out. So my surface area is going to be, now I might want to first simplify this a little bit, okay? If I wanted to, I could cross cancel here first if I wanted, or I can just go ahead and multiply everything. So if I do 6 times 6 times 3, that's going to get me 108 root 3 over 2. 108 divided by 2 is 54, so I'm going to have 54 root 3 plus, again I'm going to have 6 times 10, so I'm doing 6 times 10 is 60, divided by 2 is 30, times a 6, I'm getting 180. All right, and I could leave it just like that. Again, I would not want to add the 54 plus the 180 because 180 does not have a square root 3. So I could leave it like that. That would be its exact form. Or I could pull out my calculator. I could go to Desmos and I could do 54 times square root 3. And then add the 180, and that is 273.5. So 273.5, 273.5, and that would be square units. All right, I hope that this is helpful, and thank you for watching the video. I know this was a little bit long. Again, you can get extra credit by leaving me a comment. All right.